As you probably already know, Grasshopper is incredibly powerful at processing data, but often the input and the output data of these models need to be stored somewhere. For example, data about materials, building elements, or carbon emissions, or the results of hundreds of computational runs. Storing that data locally isn't always ideal. A cloud database allows companies, teammates, and applications to interact with the same data. So in this video, I'll show you how you can connect Grasshopper to Supabase. In this example, we'll drive the lightweight BIM model from my recent Speckle video using material data stored in the database. And then using Speckle intelligence, we can track those material properties all the way into the output model, giving us, for example, very clear insight on the aggregate price of a certain layer or the total global warming potential of an entire model. So of course, the first thing we want to do is we want to go to Supabase and create a free account, a workspace, and a project. Then inside this project, we go to table editor and then we hit create a table. Let's go with materials, save. So essentially, I would want to create materials with these properties. So name, thickness, color, price, GWP for global warming potential, and a role. Let's create a column. Let's say name, text, save. Now that we have all this set up, we can actually import some mock materials. So today I just asked ChatGPT to create a CSV with materials for me, and I'll just drop that in here and say import data. Ta-da! And then we have all our materials here. Now how do we actually connect to our database? From the URL, you should be able to grab the ID from your workspace. Let's just paste that here. And then we're gonna need an API key. Just go to project settings, API keys, and then go to legacy. And there is a service role key that you can easily reveal and then copy into your Grasshopper file. We can then start querying the database, recompute, and voila. We would want to have only the properties of a few materials where we, for example, match a name of a material. In this case, we can just create another query param with name and then just create a simple method that essentially filters our data to the materials that we really want. And basically, when we further deconstruct this payload, we can actually grab the columns in a branch. And since in this case, I actually prefer to have all the properties of a material in one branch together, we just use flip matrix, which then gives us a branch for each property for each of the material that we request here. If we would then change the request parameters, then we can easily filter all the data that we want. And when we did all this, we just make sure we ensure the right order, and then let's paste it into our main file. There you go. We connected it here. So essentially we are requesting our material properties from our Supabase database, and then we're translating into Speckle properties, which will now drive our script. So let's test this really quick. So now I'm free to go ahead and change the properties and the materials. So for example, terracotta tile. Let's go with EPS insulation, precast concrete panel, and we can see that the facade changes accordingly. Bear in mind that now all these elements automatically inherit all the properties that we grab from the database. So let's go ahead and publish the full thing to Speckle. All right, so here we have the full dashboard in Speckle. I already started playing around with it. So the nice thing is that now we can actually create widgets on top of our model and basically trace certain properties all the way to the input database. So in this case, select the property and I'm looking for price and I want to group by role, which now allows me to perfectly track which layer contributes to the total price of the facade. Now again, these are really mock-up data, so this is really just an example, but you can imagine how you can build very complex and custom workflows that are relevant to your use cases.